Hello, everyone. My name is Fatema. I'm a PhD student at the University of Amsterdam, and I'm also part of the AI for Retail Lab. And today I want to give you an overview of my research, understanding the effect of outlier items in e-commerce ranking. So I start by the motivation. So for training a learning to rank model, you need supervision. Traditionally, we could use human-generated labels, but the problem with that is that it's expensive to obtain, and also it's not necessarily in line with the actual user preferences. So the alternative to that is using counterfactual learning to rank, where we can use user historical interactions, like clicks, as a supervision. But there are still challenges involved, like we have different factors of noise and unfairness in this approach. We can divide these factors into two groups, endogenous and exogenous factors. I will explain them briefly. So endogenous factors originate from a system's choice of how to rank the items. For example, if the system decides to rank the items in their decreasing order of relevance, we can come across some cases like there is even just a small difference in the relevance scores, but it can lead to huge differences in the exposure that items receive at the end. This can be unfair to individuals or to groups of items, as you can see in this simple example. One solution to that is to make sure that we are allocating exposure in a fair way. So it comes across the field of exposure-based fairness or fair ranking. On the other hand, we have exogenous factors. These factors originate from the biases that we have in the training data, for example, position bias. So to correct for this type of bias, the first step is to estimate the examination probabilities for each of the items or each of the positions in the rank list. And then we can use approaches like IPS to weight each click inversely to the probability of examination of that item. The common component that affects both endogenous and exogenous factors is item exposure. So for endogenous factors, we have fairness issues, and we have to make sure to allocate exposure fairly. For exogenous factors, we have bias in training data, and again, we have to estimate the examination probability or exposure. So this is the core of my research, that we argue that exposure is not only dependent on the item's position, but also inter-item dependencies influence exposure. So one of the specific cases of these inter-item dependencies is the existence of outlier items. These outlier items can be items that are completely different from the rest. They stand out and attract users. These items will influence exposure distribution in the list, and hence they will influence endogenous and exogenous factors. So the goal of my research is to introduce the phenomenon of outlier in ranking, then investigate its effect on endogenous and exogenous factors, and also study the visual aspects of presentational features in item outlierness. So I will talk a bit about the proposed research and the methodology. The first study that we looked into is the effect of outlier items on exposure and fairness, so endogenous factors. In this work, we introduced and formalized the problem of outliers in ranking, and we also studied the effect of these items on exposure distribution through answering the following research questions. So we first wanted to answer, do outliers exist in data? So we looked at the public data set from TREC Fair Ranking Track 2019 and 2020. And we looked at the top 20 ranks. We used several outlier detection methods, and we used the number of citations for the papers as an observable feature. So we realized that, yes, there are many outliers exist in the top 20 data. the problem actually exists. Our next question was, do users perceive outliers in ranking? So to answer this, we conducted an eye tracking experiment where we once showed a homogeneous page without any outliers to users. This is the figure on the left. And as you can see, the position bias is obvious. Next, we put an outlier in the middle of the page and again showed this page to users. And you can see on the right that most of the attention went to the outlier item. So the answer again is yes, people do perceive outlier in ranking. Lastly, we proposed a model to mitigate the outlierness of the list while maximizing the utility and staying within the fairness constraints. In our next work, we studied the effect of outliers on user click behavior, so exogenous factors. In this work, we introduced the phenomenon of outlier bias, and we answered the following research questions. Do outliers influence user click behavior? To answer this, we went to real search logs from a popular e-commerce platform, and we realized that CTR is constantly higher for outlier items compared to non-outlier items. So we can conclude from this that these outlier items do influence click behavior as well. Next, we proposed a user examination model that accounts for the existence of outlier by adding a parameter that shows the position of the outlier in the list. And lastly, we corrected for this outlier bias and position bias at the same time based on our user examination model. So this is about my past work, and now, so far in our studies, we assume that all features have the same level of impact on the outlierness of item. For example, it doesn't matter if this item is an outlier because it has the highest price, or it's an outlier because it has the lowest average rating, for example. But our next step is to provide insights into the effect of different observable features on item outlierness. So we basically want to answer this research question. How can we estimate the true outlierness of an item with respect to several observable features? So our goal is to look at one item with all its observable features to users and decide whether this item is an outlier or not. We want to have an idea which of the features are more important or how they impact the user. So I have a few topics for discussion. First, I would appreciate any comments or feedback on how to improve this proposal in general. The second point is about how to approach the last research question. So we can look at this problem in different aspects. For example, like the first talk, we can talk about anomaly detection. But the challenge of this problem is that we don't have labels, or at least strong labels. So I have to generate the labels using crowdsourcing, for example. So this is one direction. The other directions can be look at this problem as an opportunity to provide insights. For example, we can answer questions like, do image-based features more impact users more extremely, or for example, text-based features? Lastly, I would like any input on the different use cases from different domains that can apply to this research, or the similar topics in different fields related to anomaly detection. Yeah, that's it. Thank you so much for listening. And also I would like to thank HCM Sigayar Student Travel Grant for their support.